Hello everyone, I am Om Gorge and I'm gonna solve Lab 2 in this video. Yeah, that's all. I hope from these videos you're able to understand how to write code, how to convert an algorithm that will be given in text and how to write code for it. Okay, so the first question over here, and these questions are like Div 1, Div 2 both, so yeah, bear with me here. If you only want to see certain parts you have to skip ahead in the question. Skip ahead in the video. Okay. So the first question is decimal to binary. You have to take as input a decimal number in and convert and print its primary representation. So they have given an example over here, like one is 1011 in binary, and over here they have given the whole algorithm. They have given what you have to write the code for. How do you do this? The process of converting decimal to binary. So I'll go step by step in this and I write code for each and every line so that you can relate to it. There's a small error over here. This is wrong. I'll tell you why is it wrong as well. Okay. So decimal to binary dot cpp. Touch is a new command that you might not have seen. Touch basically creates a new file. So when I do this, it will create a new file with this name. Okay, so you include simple cpp first. Main program. Okay. You create an integer n and you take it in you take it as input from the user, and then they tell you to find the largest power of 2 that is smaller than or equal to n by starting from p equals 0. Okay, so they're telling you to take an integer variable p which starts from 0, and you have to keep incrementing p until 2 raised to p exceeds n. So you will write a while loop 2 raised to p. So this power function, it basically calculates power AB calculates a raised to b. So yeah, this is what this function does, and then you have to keep on doing this until this is less than equal to n, because you have to keep incrementing it until 2 raised to p exceeds n, right? You want to break out of this loop once this value has exceeded n. So you only can keep on looping until it's less than or equal to n. And inside we'll just increment p by 1. Yep, this is up till here. Then they're telling you to decrease p by 1 to get the correct power. So you just do p minus equals 1 over here. So far, so good. Okay, then they tell you while n is greater than 0. This is wrong actually. I went through the code, I wrote a code before and this is wrong. I hope they change it when they give you the problem statement. So this should technically be while p plus 1 is greater than 0, because you'll have to print. So what you have found in p is the largest, the most significant bit of n. So let's say let's say n is 1000, because That's that's the biggest n that you can take is 1000, right? And so if we convert 1000 to binary, it will be this thing, this whole thing. So which is equivalent to this. So what p will be is p will be 10. So uh, power to p will simply be this whole thing. Uh, this zero, this zero. Basically, all of them will be zeros, just there'll be one over here. And this will have one extra bit than this. That's the reason why you're doing p minus equals 1 to make them equal. Now you want to run it for these many times, like you will run them for each and every one of them, because there is one bit for each and every one of them. Yeah, don't really get into the math if you're not understanding it. I am not good at explaining math. Okay, so then what you'll do over here is um okay, while p plus 1 is greater than 0, okay, you'll check if 2 raised to p is smaller than or equal to n. So you'll do write an if statement for this. You'll say if 2 raised to p is smaller than or equal to n, then they are telling you if it is, then you have to print 1 and subtract 2 raised to p from n. So it will be better if you store um, this in a variable power equals power 2. Okay, so the reason why I'm storing it is to avoid calculating this value twice. It's not important for you guys, but it's an optimization. It will just save up some time. So if this is the case, then what you'll do is you'll just print 1, uh, or you could directly print it any which ways, and then you'll subtract power from this, as they have told you to do over here. Okay, if it is print 1 and then subtract 2 raised to p from n. And then they are telling if 2 raised to p is greater than n, print 0. So this can be simply done with an else statement. You just print 0 in this case. And then they tell you to decrease p to consider the next lower power of 2. So you just do p minus equals 1. And at the end, I'll do an endl just to make the output look better. And that is it. That was the whole program. Let's run this and see if we're getting the right answer. Dot slash a dot out. Let's try 11 1011. That is what is given over here, which is the smallest. 1 is 1, 1000 is this, which we found over here, and it seems to. Okay, now for the second question, they have told you uh, to write a program that takes an integer n and calculates the sum of its digits. Okay, so you take an integer n and single integer representing the sum of the digits of n. Okay, for this they have not given you any algorithm, so you'll have to figure it out yourself. Okay, so you could think of it this way: touch sum of digits. All right, so let's say you have a number, and that number has it lies between minus 1000 to 1000. You can ignore this. You can use a much bigger number as well. Um, and then they've told you that the sum of digits is calculated using an absolute value sign. So for this, what you'll do is you'll check if the number n is less than 0, then you just multiply it with a negative 1 to convert it to make it positive. Okay, all right. Now, to find the sum of digits, what you need to do is iterate over every single digit one by one and add that into a variable. Okay, so let's say you have a big ass number like this. So this is my number. I want to sum up every single digit एक एक करके. So what I'll do is I'll have to extract this last. So my algorithm, what it will do is it will iterate over this thing, this whole number एक एक करके, and it will remove the last number. And okay, wait, I'll write it this way. This should make it easy to understand. Okay. So at the start, my n is this and my sum is 0. Okay. The second iteration of my loop, I will get rid of this last 8, and then that last 8 will be added up in my sum. So my sum will become 8 over here. And then the next iteration, I will get rid of this 2 and my sum will become 10, and so on until I run out of, like, I go through all these numbers and n at the end, n will become 0. and all the numbers will be added up into the sum. Sum will be all of these numbers, 9 plus 3 plus whatever. Okay. This is the overview of the program. Now to extract this last number, you will take the remainder of n with 10. So when you divide n with 10, the remainder will be this last digit. That is the whole crux of this question. So now I'll start writing the code then. Include simple in program and n cn. You will check if n is less than 0. If it is, then you will multiply it with a -1 to make it positive, and then you say while n greater than 0. Oh, I forgot one thing. You make another variable called sum, which will store the sum, as I showed in the example before. And over here, what you do is sum plus equals n percent 10. So this basically extracts the last digit of n. And now what you have to do is remove that last digit from n. So that will be done with a simple division. Now the reason why this works is because n and 10 both are integers. And so let's say you have this number. Okay, I typed. Okay, you have this number and you divide this by 10. The answer should uh, correctly be this. But since both of these are integers, this part will get removed and we will get what we want, what we are looking for. So that's why this works. And then at the end, you will just do C out sum del. Okay, this is the whole program. Sum of digits dot slash a dot out 99927. Okay, minus 99927. Try a big number. I hope that is right. I'm not gonna check it. Okay. Um, yeah, this is right. Okay, fine. Yep. Ah, let me try one more negative number. Okay, cool. Yep, it works. So yeah, that was second question for y'all.
Okay, now on to the third question. So, in the third question is they've told you to find whether a given year is a leap year or not, and a leap year has 366 days. So, the rules are simple. If a year is divisible by 400, then it's a century leap year. If it is divisible by 4 but not by 100, then it's a leap year, otherwise, it's a common year. And you have to print the correct string for each of them. So um, this is just a simple for loop. So int y if statements. If y a percent 400 is equal to 0, then you print century leap year. Else if y percent 4 equal 0 and y percent 100 not equal to 0, then you'll see out leap year. Else you'll see out not a leap year. Yeah, that should be it, I guess. um, let's see, s plus plus leap year slash a dot out 2000 a century leap year, 1900 is not a leap year, and 2024 is a leap year. Okay, so that's question 3 done.
Now for the fourth question, um, decimal to hexadecimal. Write a CPU program that takes an integer and outputs a hexadecimal representation. So this is similar to the first question that we had. The only difference is there's hexadecimal instead of binary here. So what I'll do is decimal to binary, decimal to hexadecimal. Okay. So okay. This command just copies this file into a new file. CP is for copy, and I'll just be modifying this code to solve this question. Okay. So we have a 16 system. So this part over here will become 16, and this will calculate 16 raised to n as we require it over there. This will become 16 as well. And if power is less than equal to n, okay, this will change. This logic over here will change and everything else should be fine. Okay. So over here they have given the algorithm to solve this question. You can go through it once. Essentially what you need to do is over here similar as we were printing out one. Over here we cannot print one because there are 16 different values that this thing can take. So what we'll be printing is a quotient, which will simply be n divided by power, and n will be the remainder after dividing by power. This is what they have told over here. Like print the quotient and make n as n% p. So the quotient is n by p and make n as n% p. So this is what this does. Now you'll have to write an if statement over here. If the quotient is greater than equal to 10, in this case we'll have to print a letter, and otherwise we'll just print the quotient, which will be a number from 0 to 9. So in case it is bigger than 10, then we'll have to print the character corresponding to the number. So you could do this. You do a character. Temp will just simply be quotient percent 10. This gives you the remainder of quotient with 10, and then you do plus a over here. So I'll explain what this does. Um, so if quotient is bigger than 10, greater than or equal to, then this can take values 10, 11, 12, 15, 10, 11, 12, 13, 14, 15. And 10 corresponds to A, 11 corresponds to B, and so on. So what you need to do is map 10 to A, 11 to B, 12 to C, and so on. That's exactly what this does. This takes the remainder of quotient with 10. So let's say we are considering 13, like the quotient is 13. Um, so quotient percent 10 over here will be 3. And when you do A plus 3, you will get C. And that's exactly what we wanted. Oh wait, my bad. It will be D. And that's exactly what we wanted. 13 corresponds to D, and that's what we've gotten from this formula over here. And then what we'll do is we'll just see out temp, and that's it. And you can verify this that this formula will give you the right letter each time. And that's it. There is okay, let's see if this works or not. S plus plus decimal to hexa, invalid operands to binary expression intent double. Okay, I'll make this an int. Okay, so the error was that you cannot take the remainder with a double. That's why the error was coming. So I made the power an int, and now it's fine. Slash not out. The example over here they have taken is 1267. So let's see. 1267, 4F3. Okay, that's wrong. Ah, okay, why is it wrong? Okay, wait, let me see. Decimal to hexadecimal. 1267, 4F3. Okay, fine. 4F3 is right. Apparently, the question is wrong itself, so this should be 4F3. Anyways, let's try this other number 2575 A0F. A0F. Okay, so this works fine. Okay, now moving on to the next question. GCD. Okay, write a CPP program that takes two integers and then them as input and finds the GCD N and M. Um, there is a direct there's a direct algorithm to get this. Let me see if I remember it. Sample CPP main program. You take two integers and an M. CNNM. Okay, while M not equal to 0. Um, how did it go? A person. C out N and then M equals N equals M, M equals N percent M, N equals 10. Okay, S plus plus GCD dot CDP dot slash me dot out. Okay, they have not given any examples. Okay, let's check 3 and 4. 1, that's correct. 2 and 6. 2, that's correct. 6 and 3. 3, that's correct. Okay, so um, explaining this algorithm is not that easy, and I think um, there is a video of this exact thing. Okay, hmm, okay, yep, this one. So you should find uh, this whole playlist and look at lecture 7 and 6 of this playlist. They explain this algorithm, this code that I've written over here, and he does a much better job of explaining it than I will. So yeah, he explains this whole algorithm. It's called the Euclid's algorithm. So go through these two videos to understand how to calculate GCD efficiently. This is very helpful. And this is an important algorithm that you should remember in computer science. You can also look at the other videos. Like this is a very good lecture series. You can go through them if you don't understand some parts of it. Like let's say you didn't understand loops or you didn't understand if statements and all. So yeah, you can go through this playlist. It's really helpful. It's available on YouTube for everyone. So yeah, that this was the third question.
Okay, hi everyone. So there was an issue. I finished recording everything and then I figured out that the audio isn't the audio isn't proper from the tree question. So I'll have to re-explain the questions again. Okay, fine. Okay. So the tree question. Okay, over here you have to take n as an input and draw this tree. They've told that the tree trunk width is fixed to 3 and the height is fixed to n by 2. So we break this question down into two parts. The first is to make the upper triangle and then the trunk. So first you understand how to make the upper triangle correctly. um, for n equals 7 they've shown this thing. So in the lowermost layer there are 7 stars and 6 plus signs, which means there are a total of 2n minus 1 symbols in the last line, and it starts from 1. So it goes 1 3 5 7 so on up to 2n minus 1. This is the first thing that you should notice in this question. The second thing you should notice is that there are 2n minus 1 over here and it starts from 1. So there are 2n minus 2 spaces in the first line, n minus 1 on this side and n minus 1 on this side, and on each line the spaces on either side reduce by 1. So over here there are n minus 1 spaces, over here there are n minus 2 spaces, n minus 3 spaces, so on up to 0. This is all that you need to draw this upper triangle. And also one more thing is that these symbols are alternating, so you start from the star and then you alternate between a star and a plus. So you could use the odd and even property to figure out which one to print. So you could say that for all even integers, because we start loops from 0, for all even integers you will print a star, and for all odd integers you will print a plus. So these three things will help you draw the triangle above. Okay, so now I'll explain the code over here. So there's an n, you take the n as input. The gap is set to n minus 1 at the start because there are n minus 1 spaces on either side of this central thing, and reps is the number of things that you're printing on each line. So at the start reps is just 1, reps is repetitions. It's not a good name, I should name it symbols. Perhaps symbols is a better name. Okay. All right. So okay. Then there's this while loop, while gap is greater than 0, and in each iteration we subtract gap with 1. So for the first line you'll have n minus 1 gaps, for the second line you'll have n minus 2 gaps, so on up to 0. That's why this while loop is there. Then you will print out the first n minus 1 spaces, or the first gap spaces, and then you will print the pattern in between, and finally you will print the gap spaces again, which is n minus 1 for the first one. Okay, so now let's understand the logic for the pattern over here, the alternating pattern. So this is a for loop which I hope is taught in class before lab 2 is out. It's a simple for loop. You start the loop from I equals 0 and go up to symbols, and you check if I is an even number, then you print a star, otherwise you print a plus. So this gives you this alternating pattern over here. It starts from 0, so it'll always start with a star and then it will alternate between these two. That's the logic for this. And reps increments by 2 each time, because over here there's 1, then there's 3, then there's, okay, this will be symbols over here. Symbols, okay. Yep, this is 1 3 5 7 9 ऐसे करके That's why it's always incrementing by 2. Alright, this was the logic for the upper triangle. Now for the trunk, they've said that the height is lower n by 2. So we'll repeat this loop n by 2 times for each line. And on each line, since there are 2n minus 1 symbols on this line, that means there will be 2n minus 1 minus 3, which is 2n minus 4 spaces on each of the lines in the trunk. So that means there will be n minus 2 spaces on this side and n minus 2 spaces on this side, and that's exactly what we do in the code. We put n minus 2 spaces, and then we put 3 stars for the trunk, and then n minus 2 spaces again, and a new line, and that prints out the tree. I'll show you how it works. Dot slash a dot out, let's print for 10, and here it is. So it alternates between star and plus, and the tree trunk is 3 in width and 5 in height, which is exactly how it's supposed to be. Let's run it for 7 as well. Okay, yeah, this is correct. Okay, moving on to the next question. The square pattern. Okay, this is similar to the tree question, except that it's a square and there are alternations in two dimensions. So there's alternation in x and as well as y. Okay, so for this question, the first and the last line are pretty simple to draw. You just make n stars. So that's how we start the code. You take an n and then you make the first line. You just make n stars, and then from this, I'll call this line 0 and this line n minus 1. So from line number 1 to line number n minus 2 is the main part that you have to do, like you have to alternate between these things. So from line 1 to n minus 2, you run this loop over here. Okay, so you put a star at the start of each line of the over here, so that's it, there's just a star, right? And then there's another loop from column number 1 to column number n minus 2 over here. So over here, to figure out whether you want to put a dash or a plus, or a minus or a plus, you have to take into account the sum of both I and j, which means the sum of the current row that you're in and the current column that you're in, and use that parity to figure out whether there will be a negative sign or a positive sign. Okay, so you could think of it this way, that I and j represent coordinates for each of these minuses and pluses. So this minus over here, it has coordinates 0 0, this has coordinates 0 1, this has coordinates 0 2, this has coordinates 1 0, this has coordinates 1 1, this has coordinates 1 2, and so on. And you will see that all of the pluses have odd sum of coordinates. So this has 0 and 1, this has 1 0, this has 0 and this has 1 and 2, and this has 2 and 1. Yeah, so you see that all of them are odd, and similarly these guys will have an even sum. So that's the property that you use to figure out whether we print a dash, minus, or a plus. So we see if the sum is even, then we'll print a minus, because we need to start with a minus in the top left corner. That's what they have told. Where is it? The space inside should alternate between hyphens and plus, with hyphen in the top left. So since you need a hyphen in the top left, the 0 0 will always contain a dash, and that's why all of the evens will contain a dash, and then all the odds will contain a plus. So that's how you generate this alternating pattern in between, and then finally at the end of this line you will put a star again over here, and then this repeats over all of these lines. And then finally you print the last line, which is just a bunch of stars, which is the same as the first one. So you can copy and paste this part again, and that's pretty much the square pattern. I'll run this code. One square, a out 5. Yep, this is exactly the same as this. And then 10. Okay, I should have run 8. Fine, 8. Okay. Yep, that's the square question. Now date. This is a bad question. I hope they simplify it before they give it to you all to solve. There are quite a few corner cases that you have to consider. Okay, so in this question, what you have to do is take two integers y and d as input. Y is the year and d is the day of the year. D goes from 1 to 365, and you have to print the date in the format ddmmyyyy. This format is very important. You have to make sure that there are always two digits for d and two digits for m. Y will always have four digits because it ranges from 1100 to 2900, so it will always contain four digits. But the day might be a single digit number. If the day is 1st of Jan, then you'll have to print 0101 2025, let's say, and that extra zero you need to add it yourself, otherwise it will go wrong. So that causes a lot of cases to be formed. Also, you need to since they have told that there are only 365 days, we are considering that February will always have 28 days, and we are not considering leap years in this. And you have to make sure to account for 30 and 31 correctly. So that makes the code a little complicated. So I'll try my best to answer. We consider the case for January separately, and February separately, and then we bunch together the months from March to July, and then we bunch the months from August to December, and then we write loops over them. The reason why we have to break the months at July and August is because July and August both have 31 days, and all the other months alternate between 30 and 31, and that's why we need to break it in between. Okay, so now I'll start explaining the code. This the first case is for Jan. So if okay, we take y and d as input, and then if the day is less than 31, which means the month is Jan, so then we check if the day is less than 10. If the day is less than 10, then it's a single digit day, and you'll have to add a 0 in front of it, so that you always have two digits being printed for dd. And then yeah, that's why you have to add a 0 manually while printing it, and then you just print 01 for March and then the year. If the day is greater than or equal to 10, then there's no issue, there are already two digits present in d, and then you can simply print d slash 01 slash, actually you can simplify this further. Yep, this is better, slash 01 slash y. Okay, this is the case for Jan. Now else contains all the other months. Okay, so once you're done with Jan, you know that d has to be greater than 31, so you subtract 31 days from d so that you can analyze it further. Now you have to subtract this so that you get what you want is to get d in the range from 1 to 31 or 30 depending on the month, or 28 for February, because that's what you want to print out, right? You want to print out the d, the day, and it should lie between 1 to 31. That's why you need to subtract these days which are already being counted off and add them in the month. Okay, so now we set the month to 2 to represents February, and then there's this bool called is month found, which is set to false. Is month found is basically, have you found the month that this day belongs to? Okay, so we haven't found it yet, that's why this is false for now. Okay, now this repeat loop goes over all the months from February to July. Okay, in this loop, um, we increment the month by one in every iteration, and the February case is handled separately, and all the other months are handled separately. Okay, so if the month is February, then we check that if D is less than 28, less than equal to 28, this means that the day belongs in Feb, and then we set is month found to true, and then we break out of the loop because we found the month. If it's not, if D is greater than 28, then it's not Feb, so we subtract 28 days from D and we continue this loop. This was the case for Feb. Now, similarly, for all the other months, we will check if D is less than equal to 30 plus. This is a Boolean expression. So, what this is it's checking if the month number is odd, then it will give it 31 days, and if the month number is even, then it will give 30 days. So, I'll show this to you so that you understand it. So, let's consider March. March is month number 3 and it has 31 days. Then similarly May will be month number 5 and it will also have 31 days, and similarly July will be month number 7 and it will have 31 days. Whereas uh, April is month number 4 and it has only 30 days, and June is month number 6 and it has 30 days. So this basically simplifies considering 30 or 31 based on the month number. So we just check the parity of the month. If the month is odd, then we will consider 31 over here, and if the month is even, we'll consider 30 over here. Okay, I guess that should be enough for you to understand what this is. So we check if D is less than equal to 30 or 31, the number of days in the current month, and if it is lesser, then we have found the month that this date belongs to, and then we break out. So we set is month found to true and we break out of the loop. Else, if we didn't find the month, then we subtract these number of days out of D, and then we increment month, and we repeat this over all the months up to July. Okay, all right. Now if we have found a month before July, then is month found will be set to true over here, and then we won't run this loop which goes from August to December. We will skip this and directly print out our answer. But if we haven't found a month up to July, then we have to check all the months from August to December as well. The reason why we have to write this repeat loop differently again is highlighted over here. So over here we were giving odd number months 31 days, but over here it changes to even numbered months. So from August will have 31 days now, and its month number is 8, which is even, and so is October. Its month number is 10 and it has 31 days, and so is December. It's 12. So the change in the order, the change in the parity is why we have to rewrite this part. And the only thing that changes over here is we have to put a 0 over here. So now what this is basically we are checking that if the month number is even, then this will evaluate to true and it will give 31 days over here. Okay, so this will give 31 days for even numbered ones and 30 days for odd numbered months, which is exactly the opposite of what was going on over here. And that's how it is in the months, sadly. Someone thought this was a good idea. Okay, anyways, so then the logic over here is exactly the same as it was over here. If D is less than the number of days in the current month, then we have found the month. So we set is month found equals true, and then we break out. Otherwise, we subtract the number of days and we increment month by 1. Okay, then you will eventually end up finding the right month from here. and then you will reach here. Okay, so when you get here, again you'll have to check if d is less than 10, and now there's a chance that month is less than 10. So if both of them are less than 10, then you'll have to add zeros in both of them manually. Again, this is redundant thoda. Yep, this is better. Okay. So if both of them are less than 10, then you'll have to add zeros for both of them at the start, and d and month will be a single digit number. So these zeros will make sure that you get the correct format that you're looking for. If the month is greater than equal to 10, then you don't need to add this zero over here. You can skip that because month already has two digits in it. Otherwise, if d is greater than equals to 0, then you can remove this leading 0 from d, and then you'll have to add 0 for month if it's required, as was the case in the above part. So yeah, that is the whole program. S++ dot cpp dot slash a dot out 2025 45. Yep, this gives the right output as you were looking for. 14th Feb 2025. Yep, that was this code. Okay, next question is digit difference. Alright, this was an easy question. It asks you to take an integer as input and calculate the difference between the largest and the smallest numbers. So what you need to do is iterate over each digit in this big number. So you'll iterate over 9, then 3, then 7, then 5, and then find the maximum number and the minimum number out of all of these. So that will be 9 is the max and 3 is the min, and you need to print out the difference of both of them. So 9 minus 6 minus 3 is 6. Okay, so the code for this digit difference, where did it go? Okay, yep. So first you take n as input, and then you set max as -1 and min as 1e6 plus 1. Now the reason why I've chosen these numbers is because they have told over here that n ranges from 0 to 10 raised to 6, and so I've chosen the max and min to fall out of the range, so that as soon as any number in the correct range shows up, these guys will take up the right values. For instance, um, as soon as current okay we always give max the variable collecting the max value the least value we can at the start, and the variable collecting the min value the biggest value we can give at the start, so that after the loop is run, these values will get the right values. Does that make any sense? Okay, wait. Let me give you an example. Let's say that we were to take max as 10. Okay, and the number we enter is 1111. So in this case the max value is 1 and the min value is also 1, and so the difference should be 0. But since we've set max to 10, it will never get the value 1 and it will stay at 10, and then the answer would come out as 9, which is wrong. So you always take max as the minimum value that you can. Over here you can also take it as 0, which is fine, but I would recommend you to take values out of the range, because it's easier for someone who is reading the code to figure out, like, okay, these are values that are outside the range, and that's why it would work fine. Okay, so after these two are initialized, you write a while loop while n is greater than 0. So over here what you're doing is you're finding the remainder of n with 10. So let me run this example for 5739. So if when n is equal to 5739, then n percent 10 will be 9, which is uh, uh, which is cur, and then in this loop we do n percent 10. So n by 10, which will be equal to 573, because it will actually be 573.9, but since both of these are integers, this part is dropped and it goes down to 573. So what you're doing is, in each iteration you're getting rid of the units place one by one. So the next iteration it will go to 57, then it will go to 5, and then it will go to 0. That's how n by 10 is going to vary, and n percent n will go to 9, then it will go to 3, then it will go to 7, and finally it will be 5. That's how this will run. And so core will take all the values one by one, and then what you do is you just um, you just take the maximum of mx and core and store it in mx, and you take the minimum of mn and core and you store it in mn. There's another way of doing it, which is writing this: if max is less than core, then max is core, and if min is greater than core, then min equals core. Both of these are the same, but this is slightly more involving, and it can be a little cumbersome. So using max and min functions is the more easier way out. When I write 5739, you get sorry, I ran the wrong code. uh, did diff dash 57396 as expected, and then for 492 it gives 7. Okay, this was digit difference, and finally the last question, which is LCM. So this question LCM builds up on the GCD question. If you should know this formula, that LCM of AB is just the product of the terms divided by the GCD of both of them. And so the problem boils down to finding the GCD of the numbers, and then once you found the GCD, you can just divide the GCD by the product, and then you get the answer that you're looking for. That's exactly what I've done in the code. First you take in n and m, you calculate the product, then you apply the Euclid's algorithm to find GCD. This is something that you should learn from that video. I will put the link for that video here as well. Hmm. Yep, this one. Okay. Yep, so you can go and watch this video. It's very properly explained. You'll understand what this Euclid algorithm is, and that's how you find the GCD. The GCD will be in n, and so then you just divide prod. You just divide n by prod by n, and then you'll get the LCM as required, and you print it out on the screen. So s plus plus LCM dot cpp slash a dot out. If I enter 4 and 3, that gives us 12. If I put 6 and 3, that gives me 6. If I put some other numbers, this should be correct, I guess. Let me see. LCM calculator. 923, 343. Calculate. Okay, yep, this is right. Yeah. So that was it. That was all for this lab. I hope that I was able to explain something or the other. I actually wanted to code with alongside reading the question, so that you would understand how I solved the problem. But the audio messed up in the previous recording, so I had to go through explaining solutions this way. I'll make sure that this doesn't happen the next time, and I'm able to code alongside reading the questions for the first time. Yep, that was all for this lab.